Hello friends, my name is Suchi Dubey and welcome to my YouTube channel. This is the follow-on video of the previous conceptual video that I have made on the understanding of outliers and interquartile range. In this video, we are going to identify the outliers with the help of IQR in Jupyter Notebook. So students, here is my Jupyter Notebook. The first and foremost thing that I have done, I have connected my IQR dataset. And it is the same dataset for which I have made a conceptual video. So I have imported pandas and I've connected the file. Once I'm going to run, I just quickly wanted to run over that what are the different heads. So I can see that I have two columns in my dataset, name of the participants and their respective weights. Now I wanted to understand, so I am going to run the describe function here. The moment I ran a describe function, I can see that it has given me right from count to mean to the maximum value. Now let me tell you that what is the nature of my data set if you don't remember it. My data set comprises of 20 sample in it. So there are 20 items in my data set which revolves around the weight of normal humans. So here I can see that mean that it has generated is 143 in terms of the weight, right? So 143 kg is a normal weight in my the data that I have so collected, which has given me an indication that there could be a chance of an outliers because looking at the minimum value is 5 kgs and maximum value is 780, which is quite not normal. Therefore, in order to identify that whether my data set suffers from any outliers or not, I will be running an interquartile range on my data set. So before we move on next, I just wanted to let you know the difference between the quartiles and quantiles. Now, quartiles are basically a kind of an specific quantiles that divide the whole data set into four equal parts, which will be 25, 50, 75, and 100. However, this quantile basically divide the data set into number of equal parts. So it means that quantiles can refer to any division of data, not just only the four parts of your data. The median itself is a quantile which divides your data into two equal half of 50th percentile. So having said that, let's run the quantile on our data set. So I have given the name of the variable as Q1 and data is the name of my data frame out of which I wanted to have a quantile calculated on my weight column. So here you can see that WT stands, this is the, by the way, the name of the column which revolves around the weights in my data set. So I ran a code for this that give me the 25, 50th and 75 quantile of my data set here. And when I'm going to run this, I can see that my 25th quantile is 59.25 and Q3 is 88.5 and here lies my median. So my median is 74. Now if you remember or if you have not yet seen my previous video on interquartile which will give you a lot of conceptual clarity onto that statistical method, I would request you to go back and have a look in that data set where we have manually calculated the value of median and Q1 and Q3 and it is exactly the same value which has been calculated manually, which we are doing here with the help of Python. Here, once we are done with this, then I need to find out the interquartile range, which is basically the difference between my 75th percentile with respect to 25th percentile. So if I'm going to run this, I may find it as 29.25. That's where the in between the data set lies. And the other side of the extreme, in both the side, I may have a minimum value and a maximum value, which is describe function has already generated. The next in row will come that I need to calculate the lower and upper limit. And in order to do so, if you see here that lower limit is Q1, whatsoever is my value, that is Q1 minus 1.5 times my IQR. Now 1.5 is a kind of a convention that we follow for calculating these limits. So I am just simply going with that. So Q1 minus this into our IQR is lower limit, and similarly for upper limit, I just need to add on that. And then if I run my lower limit and upper limit, I am going to see these values 15.3 and then 132.3. These are the lower and upper limit value. Now I know that there are outliers which are present in my data set. So therefore, I am going to identify. Let me see that what are those data points which are basically a kind of acting as an outlier in my data set. For doing so, I am simply running with the help of an OR function. So here you can see it's a vertical pipe, and vertical pipe stands for OR function. So what I am doing, I'm saying that using my data frame, the name of my data frame is data. Check it out, the column that is my weight is lesser than the lower value. So I wanted to know that list down all the weights which are lesser than my lower limits, which is 15.37, or using my data frame, list out all those weights which are greater than my upper limit, because those are which are not falling within the range of my Q3 to Q1 are basically the outliers for me. So I ran this code and I found this 5, 10, 400, 590 to 780. These are the outliers. And if you remember in my previous video, I have highlighted the same in my Excel file, calling that these are the outliers which will distort my results. So here on that I got these outliers. Now the thing is this, that I wanted to remove these outliers from my data set. So I'll be just creating another data frame for that. So my new data frame, the name of my data frame that I have basically giving it is DF, no outliers. And I said using my data frame, go on to my data dot. So data, this data is basically the name of my data frame. Go on to the column weight, identify that all those columns which are greater than the lower limit, and I'm running an AND function because I wanted to have in my new data frame all those weights which are more than the lower limit and all those weights which are less than the upper limit. Those are to be the part of my data frame, which is a new data frame free from outliers. If I run this, I may find this nicely drawn information in my data set. So here it is. Now if you want, now this is one such data set which you see that it is free from an outliers, and if I run a describe function on it, it is going to give me the correct response. Let us run this describe function as well. So I am going to just run one describe function on it. So the name of my data frame is this one. So copy dot describe, and if I run, you can see that mean is 72 and maximum value is 95, which is possible. Minimum value is 51, which is possible. So it has nicely, cleaned and transformed this data and store that data in a new data frame. Now, what if I wanted to get this new data frame, which is a clean data set in Excel file from Jupyter Notebook to the Excel? So I'm going to use this function that data. Now in this time, now this is my not my data, so then this is my clean data. So I have just copied this and I'm going to paste it here. So now I wanted to have this file, which I have newly created in a new data frame, which is free from an outliers, to be exported into an Excel file, and that should be visible in my folder. So what I am doing here is that this is my newly formed data frame, which is free from an outliers. I am using a function to Excel. So to Excel is this, what I have wrote, and then I have to define the folder path. What does that folder path means? It means that wherever I wanted to save this file. So I wanted to save this file in statistics using Python. Currently, there is nothing in this folder. So I'm going to take the path. So I'll go on properties. I will copy this path. I will come back to my Jupyter. And here I will just paste this. So here I have pasted. First and foremost thing which I have to do is to write down the name of the folder. So I'm using the / and statistics. using Python. That's the name of the folder where I wanted to save. And then I need to write down the name of my file. Say, suppose I wanted to give the name as output.xlsx. That's the name. And now I have to change all of these backward slash to the forward slash. And everything seems okay now. And then I can define is equal to index false. What does that index false means? It means that if I wanted to see in my Excel file, I don't want to see, I must say that the indexing of data frame which starts with 0. So I should give it as an false. It's an optional. If you wanted to see, you can make it as true, or you can just simply close the brackets it will take. Usually, I do not want to see those indexes coming in. I just wanted to see in my Excel file the name of those participants and their respective weight, which is free from an outlier. So this is what I did, and I'm going to run. No error has been generated. This means that my file is already exported into my respective folder. Let's go back and check it out in my folder. So here's my folder and here is my output. And let's see, is this the one which we were looking for? So yes, these are all my data set, which seems free from an outliers. So that's how you can identify the outliers and clean the outliers from your data set. And also you can export this data set, which is transformed one, into a choice of the extension of your own. Here I have transferred them into Excel file. You can transfer them into CSV if you like. Thanks a lot. Thanks for watching. Keep learning.